We are starting here at the top of the next page. Here we go. Hush, please. Let's go. My goal is to finish this and do the next lesson. So we got work to do. When handed a 3-page short story and asked to read it, where do you start reading? At the beginning, at the top, from left to right. Ladies and gentlemen, we read a graph from left to right, just like you read a book. Left to right. What? Now, a graph is to be read from left to right. Now, this is a big deal for mathematics. Increasing, decreasing, and constant functions. Now what I'm going to do, and I should have done it already, and I'm not together, I'm going to give you all a highlighter because you're going to be highlighting some stuff. Now, use a marker, highlighter, or colored pencil and trace from left to right any intervals on which the graph of the function below is increasing, decreasing, or constant. So here's what we're going to do. I'm going to get my highlighter, if it will let. Come on. There we go. Thank you. Come on. There we go. I want to know, when is this function decreasing? What do you think it means? If you're looking at that graph, what does it mean for the graph to be decreasing? That as you read from left to right, the thing's going down. All right. Highlight that. There and there. Let's go to the increasing one. What does it look like if the graph is increasing? What does the graph look like if the graph is constant? Yeah, all those lines are straight. Horizontal. Yeah, horizontal. Horizontal. Now, let's look on this next piece. Identify the interval of values along the x-axis for the portion of the graph that's highlighted. All it's asking you is, what x values is this graph decreasing? Now, so let's just take a look. Let's go left to right. We're looking at this piece. We're looking at this piece right here. At what x value does that thing start decreasing? -5. At what x value does that thing stop decreasing? Now, are -5 and -3 included? When x is -3, is that graph increasing or decreasing? When x is -3? It's both. It's where it turns. It's where that graph turns. When you are doing increasing, decreasing, and constant, do not include the endpoints. Why would I include -3? Do I know that at x equal -3 that graph is decreasing? The graph is decreasing coming into it from the left, but coming from the right, it's increasing. So how do I know which? I don't. So this function is decreasing from x equal -5 to x equal -3. And it's decreasing from, where else? No, we're going to use parentheses. This is, let me say something. Brackets and parentheses in certain places, this being one of them, is one of the very few places where mathematicians disagree. Long story short is some textbooks will have one, some will have the other. I'm going to follow what I think, which so happens to be what the author of your curriculum thinks. We're going to use parentheses. Nothing is happening. Nothing is happening to the left of it. So where else? Now look at the increasing. Where's this function increasing? From x equals -3 to x equals. Always use the x values, never use the y values. Last one. Where is this function constant? Now, I want you to look at the next question, and I'm going to read to you, I will post these later, what the author says. Should your intervals above be defined as closed intervals with brackets or open intervals with parentheses? Here's what the author says. The intervals should be open because at the x values of the endpoints, the graph is changing direction, not going in any particular direction. That question, I will not ask you that question on the test. Let's go to the bottom. Identify the domain of the graph function. What's the domain of that thing? -5 to 6. Now, let's talk about brackets or parentheses. Do they matter here? You bet your boots they matter here, because is -5 an x value that's used in this graph? Dang right, you got a y value there. What about at x equals 6? 6 is included. That's a closed circle. When x is 6, y is -3. There is no discussion on domain and range. What about the range? What's the range of this function? -3 to 5. Brackets. Okay. Which variable, x or y, does this notation represent? That's the y value. Now, look at the next question. If f of x equals 0 for a given, for a given point on the graph, where is the point? It's on the x-axis. Write that down and then go to lunch. Now, we're on the third question. If f of x is greater than 0, so if f of x is positive for a given point on the graph, where is that point? Above what? Why is it above the x-axis? Because that's where the y values are positive. Now, question. What quadrants then have a function value y that's positive? Quadrants 1 and 2. Good. Okay. F of x is less than 0 for a given point on the graph. Where is the point located?
Below the x-axis.
Below the x-axis. So that's in quadrants what?
1, 3, and 4.
3 and 4. Right. Now, get your highlighter back. Use a marker highlighter or colored pencil and trace the graph from left to right for any values or intervals on which the graph of f of x equals 0, f of x is positive, or f of x is negative. All right, let's take a look at the first one. What am I looking for again when f of x is equal to 0? Not necessarily. That's a constant function on the x-axis. Because remember, I'm looking for when are the y values equal to 0. Remember, f of x is just another name for y. Yes? And when y equals 0, that means the point is on the x-axis. How many places make that true? 3 of them. So with your highlighter, 1, 2, 3. Now, where is f of x positive? Anything above the x-axis. Now, we cannot tell the difference here on the x-axis with highlighting, but we'll do it when we do the intervals. And below the x-axis is there. Now, let's go to the next piece. Identify the x values for the highlighted portions of the graph. Will we use interval notation for this first one? Do I have from this x value to this x value? No, I just have very specific x values. So all I need you to say here is x equals -3 and 0 and 6. That's it. Identify the x values for the highlighted portion here. Now, remember we're above the x-axis. How are we going to indicate using interval notation? Where do we start? Is -3 included? No, because is -3 above the x-axis? Is this point above the x-axis? No, its y value is 0, which is on the x-axis. So, -3 to where? Because when x is 0, what is y? 0, so that's not above the x-axis. So -3 to 0 and (0 to 6). Now, is 6 included? Is the y value there above the x-axis? No. Last one. We're below the x-axis on this last one. Is -5 included? Is the y value for -5 below the x-axis? Yes. To where? Is -3 included? And? Is 6 included? Is 7 included? Yes. Do parentheses or brackets matter? You bet they matter. You bet they matter. I'll give a reason. We're going to skip that. I hope you know that. What's the domain of the function? What's the domain? -5 to where? So we've got -5 to 7. Are those included? Both? Okay. Range? -4 to 4. Brackets or parentheses? Brackets. Now, let's just scan through this. Look at the first question, question A. Identify the domain and range of G. That ought to not be an issue. Look at question B. You've got this function p of x. So you're going to use that. You're going to use your function f and you're going to use your function g. Now, if you'll notice here, it says show your work or explain how you determined p of 3. Look on your paper. How would you find p of 3? Yeah, just so for here when it says explain, well, it says show your work or explain. Show your work on this one. So just put p of 3 equals square root of 3 squared plus 2 times 3 plus 1 equals. So showing your work is fine. F of 0, you're going to say, I looked at the graph of f and found the y value when x was 0. You okay? Look at this question. If f of x is greater than or equal to 0, What has to be true about the graph of f? Go back to the notes we just did. If f of x was bigger than 0, meaning if f of x was positive, what did that mean about the graph? Above the x-axis. If f of x was equal to 0, what did that mean about the graph? On the x-axis. So f of x greater than or equal to 0 means either on or above the x-axis. So you're going to say the graph must be on or above the x-axis. Last one here. You're going to draw a graph that meets all of these criteria. Every one of you may have a slightly different graph and still be correct, as long as it meets these criteria. Okay? Now let's go to the back. Not that way. Well, okay, well, I guess we'll talk through the back one. On the back, you have free response number 3, correct? Now look at A. You need to write the equation of a piecewise. I want to help you with part of that. Do you notice you've got an absolute value? You can do that part. Look at the other part. What does the other part look like? A square root. That sucker's a square root. Now, let's talk about it. Let's see here. I wish I had my graph function. I'm going to have to go find out why that's not... So kind of like this, yeah? That's -5, -4. And this is 1, 1. That's kind of square rooty, isn't it? The parent function is this. Now let's talk about what happened. Remember, the parent function is here, correct? Now let's come up with a few points that are on it. 0, 0. If x is 1, 1, 1, 4, 2.
9, 3, but that's more on the outside of the graph, right?
Yeah, I can't get it on there. Yeah, you're right. Question, Maggie? Comment? Go ahead. How did it move over? Left. It moved left 5 and down 4. How do I do left 5 and down 4 in this thing? So I'm going to have f of x equals -4. Now the only question we have is, was there a vertical stretch or compression? How do you know? Because on this one, to get from this first point to the point 1, 1, you go right 1 and up 1, correct? How do you get from this point to the next point you can tell? You go right 1 and up 2. So the y values got vertically stretched by a factor of 2. Yeah. That is, that's going to be your first equation, and the second equation will be an absolute value. And I will leave you to that. Would you like for me to post the answer keys, the grading rubrics for these free responses since you've got a quiz coming? Okay, I'll do that. Does everybody have your new notes? Listen, the reason that I wanted to go ahead and do this lesson is because this lesson is incredibly similar to what we just finished. It's just doing 2 graphs at a time. So please don't be working on your pink. Please have a look here. All we're going to be doing is comparing 2 functions to each other. We're not going to be just looking at one on its own. Take a look. Which variable, x or y, do the function notations f of x equals g of x represent? Is f of x and g of x value or y value? Y value. Now look at the next question. If f of x equals x squared, what must be graphically true? So on a graph, if 2 functions, okay, Nick said hold up. What did I say? Why did I say x squared? I'm sorry. I don't know what I'm saying. I don't know. Okay. Momentary stupid. I don't know what I'm saying. Let's try something else. If f of x equals g of x, what must be true on a graph? If 2 functions are equal, what does it mean on a graph? If no, they intersect. They intersect. Their x and y values will be the same, won't they? Yeah. So the graphs intersect. Same y value. The same y value. If f of x is greater than g of x, what is graphically true? If f of x is greater than g of x, what's true on a graph? What does f of x stand for? Y. What does g of x stand for? Y. So what does that mean on the graph? Yes. Kendra said it's higher. So if f of x is greater than g of x, on the graph, f must be above g. The graph of f must be above the graph of g because the y values would be bigger. If f of x is less than g of x, what must be graphically true? F would have to be below g on the graph. Did I? Sure. Oh, sure. Yeah. Yeah. The question was, could you say here G is above F? Absolutely. F and G can only be compared on what interval? Now, I'm assuming we're talking about this graph here. Now, I'm going to show you what I'm talking about. Where does, let's see, F is the dashed line. Everybody see that? F is the dashed line. G is the solid line. At what x value does F start? -4. It doesn't include it, correct, doesn't include it. At what x value does G start? -5. Does F exist when x is -5? No. So the only places I can compare them, well, let's be a little more general, is when both functions exist, right? I cannot compare those 2 graphs when x is -5 because f doesn't exist when x is -5. Do you understand what I'm saying? I cannot compare those two graphs when x is negative 4.5 because f doesn't exist there. Can I compare at x equal negative 4? Does f exist at x equal negative 4? Now I got a hole. But right up to it I can. So, where can I compare these two graphs? From x equals parentheses negative 4. Do both graphs exist when x equals 7? So what do I put after 7? A bracket. Okay. You got your highlighter? Remember, F is dashed, G is solid. Use a marker or highlighter and trace the graph from left to right for any values or intervals that make these true. On that graph, where is f of x equal to g of x? Where are they equal? When x is negative 2, they're equal. Say again. And when x is 5. When x is negative 2 or 5. Next part. Remember, f is dotted, dashed. I want to know where f is greater than g. What am I looking for on the graph? When which one is above? And which one is f? So I'm looking for where is the dotted line above the solid line? Well, the dotted line's above the solid line right there. Is the dotted line above the solid line? No, no, no. And right there. Let's come up with the intervals. For what x values is this blue piece right here? Negative 4 to negative 2. Now let's talk brackets and parentheses. I have a parentheses on negative 4 because negative 4 is not even a part of the domain of f. Now, is the graph of f above the graph of g when x is negative 2? It's what? It's over here on this one, right? So what do I put on negative 2? And 5, bracket or parentheses? Why? Because at 5, they intersect. At x equal 5, they are equal to where? Bracket or parentheses? Because the y value at 7 is above the y value on the other one. Last one. What am I looking for? So which one am I looking for to be on the top? I need the dotted one to be above, right? No, I need the solid one to be above. I need the dotted one, which is that one. I need the dotted one to be below. Dotted one below, dotted one below, dotted one below. That's where the dotted one is below. F is smaller than G. Okay. Listen, I'm going to watch your faces, and if you have a confused look on your face, we got to get it fixed, okay? You always have a confused look on your face, Seth. Okay. All right, let's get it. Right here. Where does this start? Where does this green part start? -2 included or no? To where? Included or no? No. Do brackets or parentheses matter? You dang right they matter. Yes, Kendra?
So for like our last one, f of x is equal to g of x. But it can also be g of x is higher than f of x.
Same thing.
So what's the pilot top part? Why would it pilot the top part of it? Because that's what g.
You could have. You could have. You would have still gotten the same interval, wouldn't you? That's the big thing right here. This is what's important. So that would have been fine. The only thing I'm going to say about this piece right here is that the parentheses and brackets matter. Domain. Let's look at F. What's the domain of F? -4 to 7. Brackets or parentheses? Yeah. That's what we call, when you have parentheses on both ends, that's what we call an open interval. Brackets around both ends is called a closed interval. One bracket and one parentheses is called a half open interval. Why isn't it called a half closed interval? I don't know. Somebody just called it a half open interval and it stuck. What's the domain of G? -5 to 7. Brackets or parentheses? On both or one? Good. Oh, whoops. No, it's a range. What's the range of F? -2 to, what's that, 6? -2 to 6. And G? -4 to 4. I buy that. Okay. F is the dashed line. G is the solid line. For each indicated quantity, write in words what you are asked to find. That's a big deal in this curriculum, writing down in words, describing what you're trying to do. Then find the values or intervals. All right, we can do that. What's that asking you to find?
Value or values of x such that f of x or y equals 0.
What does that mean? So I'm looking for, yeah. Aha, what is x when y is 0? Fondly known as, you are trying to find the x-intercepts. And if you just wrote x-intercepts, I would be tickled to death. You are looking for the x-intercepts. Now, so for those of you watching the video, if you're watching it, we just made it, well, I made an executive decision that the quiz is going to be Monday because I don't think we're going to finish this. All right, next piece. The values of x such that g of x equals 0. What are you trying to find there? X-intercepts of g. Yeah. The values of x such that f of x equals g of x. What are you looking for? You're looking for intersection points. Good. Now, on this quiz, I'm going to tell you something right now that's going to screw you guys up. When it asks you to describe what you are trying to find, you're going to forget to use these words. Let's work on them. Make sure you understand the words. The values of x such that f of x is less than g of x. What does that mean in words? What's it mean? Go ahead, Maggie. Right, where f is below g on the graph. That's exactly what I'm looking for. Now I'm going to ask you a question here. What does that mean that f is below g on the graph? What's it mean? It means the y values of f are less than the y values of g. The y values of f are less than the y values of g. What does this one mean?
Where F is above G on the graph.
Exactly, where f is above g on the graph. What does that mean? What's it mean? Yeah, the y values of f are bigger than the y values of g, or you could flip it and say the y values of g are less than the y values of f. What's this one mean? The values of x such that f of x is positive. What does that mean? Where f is above the x-axis. Good. Here's what I'm going to say to you. You knew all this, you had just never had to put it into words before. You're not supposed to have words in math. Okay. Huh? The values of x such that g is increasing. How can you look, let's just say right here. What's it mean? What's going up? So as the x values are increasing, the y values are increasing. Yes. So as x moves this way, what does y do? Y moves this way. Yeah.
Stay like where X and Y move.
No. Because the definition of an increasing function is as x is increasing, y is increasing. So I want you to go at it that way. On the AP Calculus exam, if you accidentally wrote this g of x as g of x, is that what you're asking me? They would call that a spelling error and would not count that against you. Neither will I. Did I answer your question? Okay. The values of x such that g of x is decreasing. What does that mean?
As the X is increasing, Y decreases.
That's right. As x is increasing, y is decreasing. about the last one? Constant. Say again? Okay, you could say horizontal line, but I would prefer something else. Let's look at this piece right here. I want you to do this. As x is increasing, y stays the same. As x is increasing, y stays the same. You all right? Now, let's take a look. We're not going to do them all, but let's take a look because we only did half of each of those questions, didn't it? Oh, snap. Used the whole box already, huh? Let's just do a few of them. Let's just do a few. Let's do this one right here. Notice it's asking you for x values. Find them. On this one, that's kind of stinky because it's not really on an integer, is it? Call it x equals 0. Call it x equals 0. We're just going to pretend that's a big fat point. Okay? X equals 0 and 9. About, okay, question about this one. Go ahead. That's a great question. On F, you see this x-intercept right here, correct? X equals 1. Now, what I would do on this one, because you know the slope, you ought to be able to figure it. So I'd go ahead and figure it. What would the other x-intercept be sitting right out here? 15? Yeah, so I'd go ahead. Since if it's easy to calculate, go ahead and do it. Let's do this one. Where is F above G on the graph? Where is F above G? I'm looking for dotted or solid on top. I'm looking for dotted on top. Parentheses, -9. X values, 0. Parentheses, -9, parentheses, 0. Why don't we include 0? Because that's an intersection. That's where the, yeah, that's an intersection. Question? For, wait, which one am I looking at here? This one? Okay. F of x is greater than g of x. Here's the question. If you remember, we had a question like that earlier, and it said you can only compare the two graphs where they both exist. You notice that G stops right here? We cannot compare them after that because G doesn't exist. Does that help? Okay. Okay. Good. All right. F is still dotted. Oh, I'm writing in highlighter. G is still solid. You do those 6. Mia had a question about this one, and she said, because there's an arrow here, what do I do? This function is increasing forever, isn't it? Starting where? Is 3 included? No. So you're going 3. This thing doesn't stop. Infinity is not a number. You never, never, never use a bracket with infinity. It's always parentheses.